All right, so today we're going to be taking a look at how to find an equation when you're only given the vertex and a point. Well, first of all, for number one here, it says, if the point is the point 2, 9 part of a parabola with an equation of y equals 4, blah, 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 blah. Okay, so how do we know if something is actually on a graph or not? Well, this rule, or this equation of a parabola, basically describes every point that's on the parabola. So if 2 and 2 comma 9 is actually on the parabola, we should be able to plug its coordinates in and it should make a true statement. In other words, the left side and the equal side should be equal. So well, let's try it out here. So if y is 9, okay, right? So we got our x, y, and our x coordinate and our y coordinate. So if we plug in 9 for our y and x, we make that 2. So if we carefully work this out, 2 minus 1 is 1 squared. Well, 1 squared is just 1, and 4 times 1 is 4. So 9 equals 9. So that's a true statement. Plugging in that point did make a true statement, so the point is on the line. So, or on the parabola. So how about, let's just make up some other point, like 0, 7. Is that point on the parabola? Well, let's plug it in. 7 is our y. 0 is our x. So plugging that in, we get 4 times negative 1 squared plus 5. Negative 1 squared is just 1. So that's 4 times 1, which is 4, plus 5. That's not true. Okay? So this point, 0, 7, is not on the parabola. Okay? All right, so we can use that information if we want to figure out part of the formula that's missing. All right, so let's consider a case here where we have a parabola with a vertex at 3, 4 and goes through the point 6, 22. Okay, so now this is saying figure out what the a in the equation. Let's take a reminder of what our vertex form of the parabola is. So y is equal to a equals x minus p squared plus q. All right, so if you recall from previous lessons, the p is the x coordinate of the vertex, and the q is the y coordinate of the vertex. So we don't know everything about the equation that we're looking for, but we do know that it's minus 3 plus 4, okay? Because that would be a vertex form of a parabola with the particular vertex that we're given, 3, 4. All right, so we don't know what a is, but we do know a point on the parabola. So we can, just like the previous question, if 622 is actually on this parabola, we should be able to plug it in and make a true statement. So let's do that. So y is 22, x is 6. Okay, we know that this should be true, because if 6 comma 22 is actually on that parabola, it should all work out. All right, so let's just simplify this a little bit more, and we have 22 is equal to a. 6 minus 3 in brackets is 3, so 3 squared is 9, plus 4. Well, we end up with something where we don't know what a is, but if this equation is true, both sides should be equal. So we can just solve for a. So we can subtract 4 from both sides. I think we get 18 is equal to a times 9, and then divide both sides by 9. And we get a. Because both sides have to be because both sides of this equation have to be true, then a has to be 2 for this whole thing to work out. So that's our a in the equation. So we can use a point, if we have a point that we know is on the parabola, we can use it to help find other parts of the equation. All right, and our third example, or actually third example, a parabola has a vertex of 0, -6 and passes through the point 3, 21. Determine the quadratic function in vertex form. Well, if we recall, vertex form is that y equals ax minus p squared plus q. Okay, so let's take a look at what we have that we know on this parabola. We have the vertex. So the vertex gives us our p and our q. So 0 is p, negative 6 is q. And we also have just a point, the x and y coordinates of a point that happen to be on this parabola. Well, so we just recenter here for a moment. Okay, so if we have all that information, let's plug it all in and see if we can determine what our a would have to be. So 21 is the y coordinate of a point on there, and x is 3, minus 0, our p squared, plus negative 6. All right, so if I plug in those four values, I get 21 is equal to a times 9 plus negative 6. Well, that's like subtracting 6. Okay, so I'm going to add 6 to both sides. So we're going to get 27 is equal to a times 9. And we have multiplication, so we're going to undo that by division. So my a's kind of look like the 9 there. That's supposed to be an a. Okay, so that tells us that a equals 3. Okay, so then what is our vertex form of this particular parabola? Well, we know the vertex form, as said before, is y is equal to our a value, which tells us how much we need to stretch things. So that's 3. We just figured that out. X minus our p coordinate, okay, the x coordinate of our vertex, plus negative 6. Now that looks kind of weird. Let's simplify this a little bit. So y is equal to 3. X minus 0 is just x squared. And if we add negative 6 right there, that's minus 6. Or even y equals 3x squared minus 6. So there's the vertex form of our parabola, simplified a little bit. Okay, so at this point, question 4 is just another example of that. So why don't you just pause the video and give that a shot. Okay, so let's see what we got here. We've got the vertex, so that's our p and q in our vertex equation. We've got x, a particular x and y coordinate for a particular point that works on this parabola. So let's plug it all in. So y is equal to a x minus p squared plus q. Okay, that's the template that we're working from, or the vertex form of our parabola. So our y that we're working with here is negative 5, and that equals a times the x that we're working with is 2, minus the p that we're working with is negative 3. Notice when I substitute negative 3 into brackets there, because it was negative, when I put the negative 3 in, I put it in brackets, because that's going to help me with my integer rules. And then we're going to add our q value, which is negative 10. Okay, so I put my x and y of my particular point and my p and q in there. All right, so let's simplify. So we've got negative 5 is equal to a times, well, this becomes 2 plus 3, which is 5 squared, and plus negative 10. I'm just going to shortcut write that as subtract 10, because that's what's ultimately will happen. Okay, so I'm going to add 10 to both sides and get 5 is equal to a times 5 squared, which is just 25. And then to get the a, I just have to divide both sides by 25. And I can see that a is equal to 5 over 25, which is 1/5 when we reduce that fraction. So we found out the particular stretch that we need to do in order to make this whole equation happy. So our vertex form then is y is equal to a x minus p squared plus q. And because we can sort of write that a little bit more neatly, let's go y is equal to 1/5 x subtract negative 3 becomes x plus 3 squared plus negative 10 is minus 10. So that is the vertex form of our parabola, and we found it by using the vertex and a point that we knew satisfied the equation. All right, that is it.